Okay, we're going to take a look at another couple of examples, and in this case we're given rectangular coordinates and we want to express them in polar form, polar coordinates. In other words, we want an r and we want a theta, and we're given some information that says, well, r is positive and theta, stick with something between 0 and 360 degrees. So okay, we can do that. All right, we first look at the first one that says 4, 4, and this of course is an x and a y, and we want to go to the form r theta, which is polar form, polar coordinates. All right, so that's our job to figure this out. So we're going to get some coordinates here. All right, let's think about what the diagram might look like for the point, or the vector I should say, 4, 4. All right, if we have the point 4, 4, let's assume that it's somewhere right here. We could have a ray emanating like this, and we know the angle that's formed here is somewhere between 0 and 90 degrees. I happen to know that it's actually 45 degrees, but we're going to figure that out together. Okay, so let's see here. If r equals the square root of x squared plus y squared, which is given right here, okay, what we're going to do is we're going to say, well, that is equal to 4 squared plus 4 squared, which is 16 plus 16, and we take the square root of that. That is the square root of 32. And if you break that down, you actually get something that looks like this, 16 times 2. So square root of 16 is 4, and you're left with 2, 4 square root of 2. So that's the first part of this polar coordinate. And let me rewrite that for you. There we go. Now we just need to find the degree measure. So we know that the tangent of theta is y divided by x, and that's given by this formula right here. And we're going to say then 4 divided by 4 in this case, which is 1. So we're looking for a value of theta where y divided by x in the first quadrant, okay, and I guess I forgot to write that down, but we are dealing with the first quadrant, but where y divided by x is 1. That means x and y have to be the same coordinate values. So let's take a look. Where does that happen on the unit circle in Q1? Well, right here, the cosine and the sine, the x and the y value are exactly the same at pi over 4, or 45 degrees. And we're going to go with 45 degrees here. So let's take this back. This means that theta is 45 degrees. And to finish this off, we're going to write it as 45 degrees. So our polar form is 4 square root of 2 for r and 45 degrees for theta. So there's one example. Now go ahead and pause if you need to finish maybe copying this down or soak this in. But I'm going to stop for just a second to clear my board. Okay, now we're going to look at the last example. We are given coordinates 4, -4, an x and a y value, and we're going to get polar coordinates from this, an r theta. Okay, so let's see here. Again, we recall the formula that r equal the square root of x squared plus y squared, and this one's going to be very similar to the one we just did. All right, if you think about it, okay, we have 4 square plus a -4 square. So this is going to be, again, 16 plus 16. And then that, of course, is 32. And if you remember from the last time, that is 16 times 2, making the r here 4 square root of 2 once again. Again, the r value is the same, but this is not entirely the same. Okay, so we're going to show you that in just a second. There we go, 4 square root of 2. Now, I guess I failed to mention this one little part. X is positive and y is negative. That means we're dealing with something down here in this quadrant. All right, now I know that it happens to be 315, but again, this is from, just some very basic knowledge of the unit circle and what it is really that you're dealing with. But it's okay. We're going to take a look at it together. So let's talk about the angle first. We're looking at an angle that makes a rotation like this. And we know that we're going to be somewhere in the neighborhood of between 270 and 360 degrees. Now I use the term neighborhood lightly because in math, the neighborhood, being within the neighborhood, is actually a mathematical term that you might find in an advanced course such as real analysis. But that's a subject for another time. All right, so let's see here. If we are finding a value, we're going to be in quadrant 4. All right, and let's consider that the tangent of theta, which is y divided by x, is going to be -4 divided by 4, which is a ratio of -1. That means that x and y have to be equal in magnitude but opposite in sign. And so what we're going to do is we're going to go to quadrant 4 and we're going to look for where x and y are the same but opposite in sign. And that should be very easy to point out. Let's go to the circle now. Let's see here. Yep, we found it. Let me point it out to you right here. X and y the same but opposite in sign, 350 degrees or 7 pi over 4. So 315 is what we're looking for. All right, and so we're going to go here. We're going to say that theta equals 315 degrees. And all we have to do left is fill that in here. And we have our polar coordinates. So again, two really nice examples where we're going from rectangular, x, y coordinates to polar coordinates. And, fairly easy, fairly straightforward if you can just follow the formulas. So as always, if this was helpful, be sure to like and subscribe.